Hello everyone. I am Aviral Kumar Goyal, a second year computer science student at BITS Pilani, Goa campus. About 6 to 7 months ago, I made this small project of a steering wheel simulator to play games like Asphalt 8 and Asphalt 9 Legends with the steering wheel in hand to get the experience of driving without investing for very expensive Xbox and PlayStation steerings. I posted the project on LinkedIn as well as on YouTube. On LinkedIn, I got a wholesome feedback with several appreciative comments, and on YouTube, I've been getting tutorial requests. Now, I'm not a YouTube content creator, and I got engaged in some college work, and also with colleges going online, it gets frustrating looking at the screen the whole day. And also, my 4 year college trip to Goa got shortened to 6 months. So, anyway, what I'm saying is that I'm a firm believer in better late than never. So here I am. The way I have structured this video is that I'm coding line by line with you while explaining what we are writing. So let's dive right in. So this is the code of the steering.py file. This helps me control the cars. The way it works, I'll be going line by line and basically recreating this code. Okay, so let's get started. It works in a few steps, as you can see here on the screen. I have written first two. After that, the first is capturing the image from the video camera, and then we have to apply some filters, some calculations, some transformations to the images that we've captured, the live video stream that we have captured from the camera, for OpenCV to detect the boundaries when I control the car. Okay, so I'm converting the image from RGB to HSV. I'll be talking more about the formats. Then to the HSV converted image, we apply a Gaussian blur. Okay, to the HSV converted image, and then in the next step, what we do is that we apply some morphological transformations to the Gaussian blurred image. I'll be talking more about what these morphological transitions as are, and also attaching a link in the description so that you can read more about that. And finally, what we do is we detect the contours. Contours are basically the differences in colors with respect to the background, the color of the foreground. So we'll be searching for these contours using OpenCV, and then finally, when we have detected the contour, we will navigate our car using those contours. So yes, navigate the car. Let me just comment it all out, and let's start programming. So first of all, what we need is obviously OpenCV, and for video stream, we can use the video capture method of OpenCV as well. But the iMutils video stream feature was a lot smoother when I compared it with OpenCV ones. So I'm using the iMutils here, and the video stream particularly. Yes, and we will also need numpy. Okay. Other than that, to send the inputs to the keyboard. So you know how the car works, right? These racing games have a WASD format, and the games I'm talking about, the Asphalt Legends and the Asphalt 8 Airborne, what it does is these are auto-accelerated games. What I mean by that is you do not have to press W to accelerate your car. Car accelerates on its own, and you just press A and D to navigate the car, and space to what? What do you press space for? How long has it been since I played this game? Yeah, you press space bar for as far as I remember for Nitro, right? So yes. Um, So to send input to the game, I was exploring different libraries. As you can see, I tried to use this keyboard library, and there's also a Pi input keyboard library, and I also experimented with um, Auto GUI, Pi Auto GUI. It's not here, but yes, I tried it as well. But the thing is, there was some lag in all these libraries. So, as always, Stack Overflow to the rescue. Uh, I discovered this directKeys.py. Someone on Stack Overflow was generous enough to have the whole code of this library uploaded in the answer. I'll paste the link to this answer in the description as well. What it does is it mimics the hardware input of the keyboard. So this also helps you bypass that some games they have bot detection mechanisms. When you're playing online games, they detect if the keystrokes are coming from the keyboard or are from external third-party software. So since I'm using the hard-coded values here in this library, those bot detection algorithms will not be able to detect, and this is a lot faster. I'll show you in the demo how fast it is. Okay, so yes, coming back to this, we need to uh, import the respective keys here. Import from direct keys. We will import what we need: a key, and we need a D and a space and a release key. Hmm. So we need a release key as well. And now, uh, from the first for the first step, what we need to do is capturing the image. So let me just make an object of the video stream. I will define the source as 0 so that it detects the camera inbuilt in my laptop, the integrated webcam. Just call it to start. Okay, and now let us enter a while loop because we need to continuously have this running, right? Uh, the contours, the differences in the image, the front and background. Basically, when the color overlaps in one of the boxes, we need to detect it as soon as it does. So all of this is running in an infinite while loop. I will define that currently there are no keys that have been pressed. And now let's just read our image equals camera.read. This image is a normal variable and cam is the object of the video stream that was made from inutils, right? The thing is, the yes, I have noticed this a lot, that these images, when you try to read them, are inverted. Like they are literally inverted. Your right will show as the left in your laptop. So to fix that, let me just do a small image.np.flip. Okay, axis one here basically means the vertical axis. That is done. Now, as I said, what is step two? Convert RGB to HSV. RGB. So, all your images can be represented using RGB. RGB stands for red, green, and blue. So it is on the scale of 0 to 255. I can show it. What I mean by that is from 0 to 255. Suppose if I do 234, comma what 121, comma 123. This will again be a color. So all your colors can be represented using the RGB, but that is too much information for OpenCV to process. What we do for that is we convert it into HSV. What I mean by HSV is HSV stands for hue, saturation, and value. It basically filters out all the additional information and just uh, extracts one color that we need. Okay, so let me just convert the image to HSV. cv2 dot color underscore bgr. Okay. The way OpenCV works is that it processes images as blue, green, red, not red, green, blue. Okay, so we are doing BGR to HSV here. Now we need to apply a Gaussian filter, Gaussian blur on this HSV converted image. So what I mean by Gaussian blur here is, I'm sharing the display, right? Yeah, I'm sharing the display. So I'll just go over here and show you what is meant by Gaussian blur. OpenCV. I highly recommend you to explore what these functions are on your own. Just do what I did right now. Type OpenCV and the function name. Okay, and this is the Java T.1. But if you scroll a little further, you will find the OpenCV docs. Okay, docs.opencv.org, and you should give this a read. This is the official documentation of OpenCV. Whenever you are stuck with a function, just open the corresponding documentation, and they have very nicely explained all the mathematics that runs under the hood. Okay, so if you go to Gaussian blur, it blurs an image. What is the effect of this Gaussian blur? Let me just show you. See, as you can see, this cat is fairly detailed here and it is blurred. So basically we are denoising the images. We are removing noise from an image, the extra data that we do not need, so that the results are accurate. Okay, what are the inputs? The source image, the kernel size, and the sigma x. So this sigma x is basically the standard deviation along the x-axis, and then we have standard deviation along the y-axis as well. You can read about Gaussian blur. There's a nice Wikipedia article on it, and OpenCV documentation does fair justice to it as well. Not this one, the previous page that I showed you. Yeah, let's go back a bit. Yes, this page teaches you about various types of documentation and various types of blurring. Sorry. Okay, just go through all this once. Whatever functions we are using here, do check out the documentation for there. Right now, I'll just be using them directly. Okay. The idea behind this function is to blur the image so that we filter out the excessive information that we have. Okay. Now I have to define a kernel size. What this kernel size is, how it is distributed, you can find enough resources online, and that is why I suggest you to give that a read. 11,11 is a fair value. Sometimes we use 5,5, 5,55, whatever you may seem to like. There is some maths involved behind this. There is some maths involved behind this. That is why I recommend you to go through this. Okay, and we do not need any standard deviation, so that is why 0 here. What do we need next? Morphological transformations to the Gaussian blurred image. Let's do that. We will call it a mask, and first of all define the range. Okay, to define the range, here now comes an interesting part. uh, so you are telling the OpenCV library to filter out whatever there is in this range. What that range will be. This range will be color value and the blurred, using the blurred image basically filter out these colors. I'll just show you. Okay, let's call it color upper, comma, color, wait a second, yeah, it should be lower comma, yes, it should be lower comma upper. Yes, what it is, color lower and color upper are basically the HSV values. Here comes HSV again. I will define them right here. It will be an NP array. Okay, and here we have to input some values. Similarly, for the upper, we have to input some. Just bear with me for one more second. Okay, I'll explain what this means. What this value will be here is that here we'll be using a simple color.py file to determine these values. What I mean by that is, let me just play this program. You guys will get a good understanding of it. Oh, wait a second. Is it working? Why isn't it working? What happened? Oh, okay, okay. My camera is being utilized by this OBS. So I'll just free my camera from here. One second. Remove. Yes. We removed the camera from OBS. Now it should work. And it does. What it is. Using these HSV values, you can filter out the excess information, okay? So this is what I was using. These two are the color markers in my steering wheel video, as you can see. So I just have to determine at what values I can filter out the excessive information from this, okay? So that only these two colors remain. Yes, basically filtering out the excessive information that we have, right? So we make a note of these HSV values and use them there. These values you can filter them out. As you can see, there is some you there are some points of my red shirt still showing up. So I have made a note of the optimal values that I was using in my program. I'll be using the same values in this tutorial as well. Okay, so for me, the values for my color, every time you need to change the color values. This is the same thing that you need to do. Just determine the HSV. Okay, and the upper one is generally this 180 comma 255 comma 255. So we are asking CV to look in this range of color lower and color upper for the image, in the image, to look for this range. Now we will apply our morphological transformations. So yes, MorphologyEx, and the parameters, the arguments it takes, I will explain this. What it means is, okay, so I'll be using the same image, and then let's do a morph open here and feed in np.once here. Okay, okay, that should do it. That should do it. And similarly, we need the same line for closing. Morph underscore close. So what morphology here means is that morphological is a special CV2 function. I'll show it to you. Wait, let me close this. Okay, we didn't pause the last program. So, yes, I have it here in one of the tabs, the official documentation from Morphology. Yes, CV2 Morphological X. So, it does morphological transformations on the images. What these transformations mean? Okay, so what we did here, we have different morph types, and as you can see, I use the morph type morph open, and then I use the morph type morph close. So the morph open what it does is it first erodes the image and then dilates it. Morph close dilates the image and then erodes it. What is meant by dilation and erosion? Let us check this link out here. This Java T point article explains it very well. This is dilation. What it does is basically so what it does is basically so this is what dilation does. I guess the image fairly depicts this enough. You can have another look at this image. So it filters. This is again another method of filtering out excessive information. And then erosion is the reverse of dilation. What dilation does is it calculates the maximum value of pixels in a neighborhood and then switches the pixels. So the thing we did here, 5 comma 5 np uint 8. So what it does is it will replace 5 comma 5 pixels. Okay, 5 by 5 pixel matrix. It will replace the that with the maximum values in that particular matrix. Okay, this is all matrices. Images are stored in OpenCV as matrices, right? Images are stored as numpy arrays. I hope you guys are familiar with that. If you're not, just make a note of that. Images are stored as arrays. Okay, matrices, arrays, whatever you may call them. um, and dilation just filters out the excessive information, and erosion is the reverse of dilation. So erosion highlights the darker areas, basically the okay, you can see the difference in these two images here. I'll paste the link of this article as well in the description. And morphological close just does these two operations in the reverse order. These are the basic masking practices that we follow to denoise an image, applying the converting image to HSV and then applying Gaussian blur to it. Let's call this value as HSV so that we do not have any confusion in the future. Okay, and applying Gaussian blur to it, and then morphological transformations to the same image. Okay, now moving further, what we need is to search for contours. Where will we search for contours? We have to search for contours in the image. What do I mean by contours? Let me just explain it to you. Okay, first let's write this code. What it basically means is the area in which we are searching for color variations. So from 0 to the full height of the image, I have to define the height variable here first. Height equals image.shape, and shape is stored as, in the first element there is width and then there is height. Okay, this will be width. Of contour, we need the contour for the full height, not for the full height, sorry, for half the height. Okay, we are dividing the screen in two parts mainly. I'll explain this to you. Just give me a moment. And I need my down contour for, yeah, the lower 3/4 of the height. Okay, yes. So we have our up contours defined from for the first half of the screen. Okay, let me just pop up paint and explain it to you. Suppose this is our image. Our up contours are the first half of the image. Man, I forgot how to use paint. So this is where the CV will be looking for colors in the first half of the page, and then our down contours start from 3/4 of the height. Why I'm doing this? You'll get a you'll get a much better understanding later. Okay, so this is for the nitro, and this one is for left, this one is for right. Steering left here. Wait, let me just change the color. This is orange is for steering left, red is for steering right, and the lower box is for nitro. So what we have defined here is we are instructing OpenCV to look for colors in the first half of the page and then in this box. What is this? It is expanding from 3/4 of the total height to the end of the image, and in width it is I've just divided it into five what do you call columns, and it is expanding from what the second column to the third column. Okay, this is what this code says. Now we will use the findContours method. Okay, let me just define it. Yes, this is the area in which it has to look. This is the retrieval method. You can read more about it in the documentation again. These are some very you know mathematical involving functions based on mathematics, using matrices operations. Okay, um, for now we can just use this as it is, but I highly recommend you to at least look these functions up, read the CV documentation, find contours, MorphologyEx, Gaussian Blur, at least these three. Please do give them a read. Okay, and then to explain this third parameter, I have a nice article I found online. Uh, oh man, it's a constant battle of switching between caps lock. And then we will call imutils on it and ask it to grab these contours, right? We need the similar thing for the down contours. Counts down, counts down. Yes, so let me just talk about that third parameter we had. Check this out. The approximation method. What we're using here is chain approx symbol. What it means is this findContours method will look in this area for the colors, okay, and draw a boundary and return all the points on the boundary, okay. Now, how many points do we need to define? It is defined by the third parameter. As you can see in this example, it is returning all the points of this boundary, okay. Here we have used chain approx none, so it is returning 734 points. But if we use the chain approx simple, it is returning only 4 points, and that is what we need, right? We have the as you can see in that image, we have the rectangles and we just need their endpoints, so it makes our job fairly easier that way, okay. Now, this was all the CV was doing. OpenCV's work is almost done here. Below this is just fairly simple Python logic. If there is anything, if there are any boundary points in this available, okay, then we steer the car. So to do that, we figure out the maximum contour in the mask. Uh, yes. And on it we will apply something known as moments. So moments are basically functionality in CV. How it helps us is that it helps us to calculate the centroid, perimeter and area of the boundary points, okay. So I will apply moments to C, and this is the official documentation. As you can see, the centroid is given by this m10 upon 00. So we will use this to find the centroid of the rectangles just created, okay. Why we need this is basically to determine whether our the color is in the left box, the colored rectangle, the purple colored rectangle is in the left box or the right box, and then to steer accordingly. That is why I'm only using the x contours. I'm only finding the centroid of the x coordinate, and I do not need the y coordinate of the centroid, okay. Because we do not need the y coordinate because uh, the way we have set the area, the down contour will be only activated if it's in this area, so there's no point, okay, of to have that y coordinate as well. M10 divided by, as I remember, it was M00. Now, if cx less than width, width by 2, yes, it's in the left portion. Okay. So here the thing is that if I just do this now, width by 2, as soon as the I do not have any option to move the car straight, because it just divided in my screen into left or right. So instead of that, what we will do is we create another rectangle here, hmm, and color it with black as well. Let's just say we color it with white. So this will be our empty area. If the contour is in this area, the car does not move left or right. Okay. So I tested out. I made this area to be 35 pixels long. So if CV, this basically says if the x coordinate of the centroid of the contours of mask is in the what is in this portion, then what we will do is we press the key A. Now see, this press key we imported from, okay, we didn't import it. We need to import it from this direct keys, and this press keys here is a function. It gets the hex key code. We will have the hex key code of A. So I'm saying press key of A. So this passes in the hex key code, and it calculates, it calls the C types and the input, and then just sends the input, the hard coded keyboard based input to the machine, okay, to your operating system basically. So we press the key A, we change the key, we defined a key here, right? Key equals false. Okay, okay. Also, we need to, yes, huh. So we defined, we'll call it true, and we need to make a list, current key, and in that we will append basically to have a record of what key was pressed last. So current key, I'll define here. There we go. And similarly for right side, we press that key D and we do this. Okay, this is for the upper half. We need a similar functionality in the lower half as well. So let me just come here and say if counts down are greater than 0, basically their length. If it's greater than 0, then we have the color in the lower area. So we press the key. Imported press key or press key? What was it? It was capital K, right? This will throw me an error later. I hope I imported it right. Nah, I didn't. Also here. Yes, and then we press the key space. This is for nitro. Hmm? We mark the key as true, and we append it to the list. Now to just have what? What do we need next? Yes, we need to draw on the image to basically intimate the user that this is the left portion, this is the right portion. We do that using cv2.rectangle. So we have the image here. Just draw a nice little rectangle here. The way CV2 creates rectangles is that we give it the diagonal endpoints. So let's give it 0, comma 0 here. And I actually have a note of these values. But yes, you can make it according to your own, convenience or wherever you want to make them. So this is the left rectangle that we have. Okay. I need one more parameter. One more parameter will be its color, and then the intensity, basically the line width, and then we have it. There we have it. Let's just put text as well. Call it rectangle. Image, comma the text we need. Okay, and 0, comma 30. Yes, I have these values noted in pixels. You can use your own values, or you can use some width, or width by 2 or height by 2. By the way, this double slash means floor. So what it means is that if suppose your width was, for example, if your width is 150, and if I do by 2, that will basically give me what? Okay, this doesn't prove my point. Let's make it 151. Okay, uh, so this will give me 75.5, but with the floor operation, 151 double by 2 will give me 75 only. Okay, so pixels do not have decimals, that will throw us error, so that is why we are using double mod here everywhere. Okay. Hmm. We need to define the font. Let's do Hershey. Okay, and then the color. This is, as far as I remember, this used to be green color, green or red, I don't remember. Hmm. And that is it. And I'll copy it thrice for right, for nitro. This will be plus 35, height by 2 is fine here. Oh, no, 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 no. Yes. These are basically the endpoints of the diagonal. I hope you guys are following through this. Uh, just some basic stuff. Don't fret much over it. Hmm. Does this make sense? If I have a diagonal from width by 2 plus 35, where is my paint? Uh, this is my width by 2 plus 35. This is one endpoint. Okay, and what I have, comma 0, right? So I need it to be width, yes, the entire width. Width and height by 2. Okay, and this used to be 440. Similarly, the lower box that we had, you guys must remember, I divided the screen in 5 boxes, and then just using this. It's recording, right? Yes, it's recording. Sorry, I'm a little fuzzy. Actually, this is the first time I'm, making a tutorial. And this tutorial in itself, it took me. Basically, I'm a heavy procrastinator. So I've been procrastinating to make this tutorial since what, a year now. No, 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 not a year. We created this project in November, as far as I remember. So yeah, 7 months. That's a long time. Okay, what do we have next? Yes, this is wrong. Why do I have this? 3 into width. Uh, this is just putting text and putting rectangles on the image. You guys can skip this part if you want to. Whosoever is watching the video, you're free to skip this part. Okay. And finally, we show the image. cv2.imshow is to create a window. Steering is the title of the window, and what we need in that window is image. Okay. Before that, a very important part before we go on the demonstration. If the key is not true, okay, and there are no keys in current key, Then we need to release the key as well. Okay, otherwise once you've pressed right, once if we do not do this, once you've pressed right, the car will continuously keep on going right. And this particular thing took me a long time to figure out. My cars initially just used to move round and round in a circle. um okay, so to end the program, as in you gotta stop the video, right? Gotta stop the program. We will just do this. Wait key 1 and 0xff. Okay, and if key equal to odd q, we will break it. This will break out of the while loop. And cv2 dot destroy all windows. See this thing here that we did, and 0xff. This is again Windows specific. If you want to have a platform independent application, you will have to use libraries that I mentioned: the keyboard library, the PyAutoGUI, PyInput library. But of course, there are some latency issues in that. So that is why I'm using this. Okay, and with that, we have completed the code. It should run. Let's run it. Try it out. Oh, okay, okay. So I've made some typos here. Um, this should be simple. Yeah, and this should be small m. I hope there are no more. Let's try it again. Oh, okay. So this is the known error, the famous error, and again this is Windows specific. You won't see this error in POSIX systems, that is your Linux and Mac OS systems. We will just typecast the image to a NumPy array, and this will solve the error. And yes, we have a Python window. Oh, okay. So we messed up the height and width. Yes, this should be 1. This should be 0. Please work it this time. Okay, so let me just bring that out. Okay, so um okay, there's another error. Yes, I gotta mention key here, and that is it. I'll open a notepad for testing. Let's run the code. So yeah, as you can see, if I tilt it towards the right, it's typing D. Towards the left, it's typing A, and at the bottom it's typing space for nitro. And that is it. That is essentially it. This is the whole project that was about. It was about recognizing these keys. Alright guys, so this was essentially the code for the steering wheel Pi project. And this project, with this project you can play games. You have made your own steering wheel. The point, I'd like to highlight a few points here at the end. See, this is essentially the whole Python logic. We are just pressing keys here. In case your game has different keys, or It is a key where you have to manually press W. You can modify these three functions according to your own need, and create a separate project and customize it according to your own game. And about the functions, as I said, please do read about these functions, the findContours, the MorphologyEx. This will really help you understand the underlying mathematics that goes into this, and also the workings of OpenCV in particular. And that's it from my side. Thank you for watching. Have a nice day, or a nice night in case you're binge watching this at a nice night. That's it from my side. Have a nice day, or a nice night in case you're binge watching this at night. And thank you. Avril Gohil signing off.